Okay, good morning. Please turn on the camera. Let me know you are here. I would like to start the lesson right away. Now, after I make I check the right, I will start the lesson very shortly. Anyone who see 麥建陽咧唔加靜，冼俊琪、楊仲賢、翁成軒。Rita, could you please open the camera? And we will start the lesson now. Now, last time we just stopped at the very last method. It is the comparison. It is the chemical method. We call that titrimetric analysis. Okay. The core concept behind is to make use of the chemicals, right, to determine the concentration of the chemicals formed or consumed at regular time interval. Okay, so this is what you know about this chemical method. So what do you think about this chemical method? You may find that, Mr. Chin, if we can really choose, I tend not to choose this type of method. Okay, because in between the steps is rather troublesome. First of all, you need to do the sampling. Okay, while you do the sampling, it will take you time. You know, the titration takes you time. But even though I just extract a very small amount of samples to determine the concentration of the certain chemical, for example, acid or alkaline, remaining or or newly produced, you may have a risk of contaminating the chemicals inside. So it may affect the overall results. So this is what you may know about this method, and you may know the procedure. This is it is highly needed. You need to get to know the procedure. Now, first of all, extract a known small amount of the chemical and add it into the excess or large amount of cold distilled water. Now, this is to rapidly decrease the rate of the reaction inside the solution mixture. We call that quench. We will see the word quench, right? So you should use this technical term. And later on, you are going to titrate the sample with a standardized or standard acid or standardized alkali. Okay, by doing so, you can determine the concentration of hydroxide ions or hydrogen ions. It depends on the questions. Okay, so remember, take a look on the questions, whether or not it shows it's hydrogen ions or hydroxide, either on left hand side or right hand side is also okay. Now, but of course, the difference is on the rate curve later on while you do the data treatments. Any questions so far? You get to know what is that? Now, just recall your memory about this procedure. Now, so in order to get to know All those methods are, you need to do some comparison. Okay, we are going to do some comparison first of all. How can it be done? Now, first of all, I would like you guys to first of all, find out this method, right? First of all, advantages and disadvantages of having this titrimetric analysis to follow the progress of the reaction. What do you think about this advantages? No? Let me put it this way. You may find that quite hard, isn't it? Now I will see somebody. Anyone who can try? Or maybe you will write down advantage or disadvantage. Most of the time you are going to compare, right? This method and the other method, right? So the other method, we usually tell it as a physical method. So my question is, I try to, we adjust the question a little bit. Okay, what is the difference? Can you compare the major differences between titrimetric analysis and other, in general, all those physical methods? After talking about that, all those. Now I'll give you 2 minutes. Okay, you think for a while and try to have a comparison. I repeat, you are going to have a comparison. What are those physical methods? Just like the change in volume of gas form or the consumed, the change in mass of solution mixture, the change in pressure, etc. Okay, so first of all, type of reactions. Okay, it only suits for certain type of reaction, right? For physical method, what are they? Can you think it? Type of reactions. Zhang Dale.
Change in mass.
Change in mass, right? Compare the difference, right, between the two. Would it be applicable to all types of reaction?
Yes.
Okay, you get my point. The question is applicable to all types of reaction. Which one? Which one is yes? Which one is no? Or partly?
Physical like method.
Physical method, it can be used to apply in all reactions, isn't it?
Yes.
Yeah. How about neutralization?
No, because you need to do titration.
So go back to the own question. Does it is it applied to all types of reactions? Some of them is no. So it depends on the some of the physical property change will be easily seen. I would use it, right? Can be applied in certain reactions only. For example, the reaction involving the gas formation. Okay, of course, you will use physical method. Now, you may choose either measuring what change in volume of gas, change in mass of solution mixture, change the pressure in a fixed container, okay, container fixed volume, etc. It's easily understood, but if you find some other reactions, for example, changing color, okay, I can also use colorimeter to measure the color intensity, changing color intensity of the solution mixture. So, but what if I have got a moderately slow reaction in which there is no significant change in the observation. For example, no color change at the end of the reaction. So it is quite hard to use that physical method. Can you get my So titrimetric analysis, how about titrimetric analysis? Can be applied to most reactions as long as you have got to know what chemicals, the concentration of what chemicals should be considered, right? You may simply start from this. Now, for example, in the equation, okay, you may find there is a drop in concentration of hydrogen ion hydroxide ions, right? I know I can do titrimetric analysis. Can you get my point? So this is so. For example, you may have got an acid alkaline reaction, redox, okay, etc. Of course, you can do titrimetric analysis, but for physical method, is a method. It can only be measured using only a certain change in chemical property. For example, a gas formed or consumed, color change, etc. Right? All those can be. I will use physical method instead of titrimetric analysis, right? Because you know that based on that two, right? Physical method seems to be easier to handle, right? Second, what are the differences between them? 楊仲賢 think of some other comparison besides whether or not it can be applied to all types of reaction. What else can be compared? Hello, Matthew.
Yes.
Can you think of some? Yes. Anyone who can help? Anyone who can help? How about the you know that you are going to intervene the reaction, right? For titrimetric analysis. How about physical method? Okay, Matthew. Hello. Từng sai cặp thôi. Do you need... For titrimetric analysis, do we need to?
No.
No.
But titrimetric analysis needs to draw the sample, but physical methods does not need to.
Yes. No. Okay. So it's just a monitoring, right? So it comes to a concern to number 3. Okay. Can we have a continuous monitoring Is it a continuous monitoring of the concentration change, right? In terms of concentration change. Is it a continuous monitoring?
For titrimetric analysis, yes. But for
Yes.
physical methods, no.
Physical method, no. So to your understanding, what is meant by continuous monitoring?
Checking the results in regular time intervals.
Checking the result in regular time interval. Okay. To the others, do you think so? To your understanding, what is meant by the continuous monitoring? It seems like a CCTV, right? It seems like CCTV to keep track of the whole progress. It's not just every regular timetable, but every second, every 0.1 second. Okay, so by doing so, we can get continuous data. Can you get my point? So my question is, which method would you help to plot a graph, for example, like this, a very smooth curve continuously? For example, the concentration of product versus time, I will get that curve. Which method is possible? Chen Yu.
I think it's physical method.
Physical method, yes, for physical method. As long as you have the gas range, you have got a data logger connected to computer, you can get that continuous data. But for that, no. Why? So it depends. So because of what? Of human limitation, titration, quenching. Those process takes you some time. Takes time to complete. But for this, as long as you have the data logger connected to computer, you may do the continuous measurements. Of course, you should have some sensor as well. Some sensor data logger connected to computer, you may have this one, a smooth curve that will come. But for titrimetric analysis, no, because you need to extract regular time, for example, to the best you can, maybe minute per minute, for example. Even though you can do it as fast as per minute, or what you can plot will be something like this. If I put it as product concentration versus time, so you can only do your data treatment only here by drawing a smooth curve and to project, right, this effect, right, the shape of the graph. So you are going to draw this by yourself, but not directly got from the real-time measurement. It comes to number 4. It comes to number 4. So the time needed for the monitoring of the reaction. It comes to this. So the for titrimetric analysis, it will take you so much time because of quenching. Okay, so which means that it is quite inappropriate for some rapid reactions. So what is said to be rapid? Now, for example, the reaction takes, for example, 10 minutes to complete or 5 minutes to complete. So you may find the whole procedure too fast. okay, to complete. But if you find that it's 5 minutes, if apply to physical method, you may find that, yes, this one, it seems to be more possible. Yes, this one, why? It can be taken rapidly because you are going to have a real-time measurement most of the time. But because of the fact that I say as a continuous measurement on number 3, you know that it's less time consuming. So it is appropriate for rapid reactions. The reactions evolving quite fast to complete. For example, ribbon react with dilute acid. All those will be finished within 2 minutes. Okay, it's said to be fast. It's said to be fast enough, right? But once I put it into titrimetric analysis, you may find that, well, that may be too fast, right? That reaction between the piece of metal and the diamond, that may be too fast. Because even though I before quenching, I already spent you 1 minute to extract that solution. So this is what you know about the comparison. Do you have some more? Yes. What is the equipment needed for that too? What is the equipment needed to carry out that experiment? For titrimetric analysis, you may use some simple volumetric analysis tools. For example, volumetric, no need to volumetric fast this time. It's just a pipette, conical glass, and pipette, conical glass, burette. They are quite commonly found, but you are going to take the may require some specific equipment or apparatus. For example, colorimeter or some other meter or the data logger sensor, right? Plus the computer, etc. So, okay, I just give you a 5-way of perspective for you to compare the two. So you may find that seems that physical method seems to be easier, but it has its limitation. Because not all chemical reactions will show those easily observable change that can be measured. So we can not choose, but go back to titrimetric analysis. But for physical method, if you really want to do a continuous monitoring, you may need the help of the data logger in the computer. But of course, for physical method, you may be asked to do some discontinuous data by, for example, by you, human. Now, for example, reading the change in volume of gas every 10 seconds. Okay, you may still come to that type of curve. Okay, but it seems like technology really helps. If you can have a sensor data logger connected to the computer, you may get the continuous data like this. Okay, but for titrimetric analysis, sorry, no. So far, we can only produce that type of graph, but not this. We cannot find it in titration. because the titration is done by you. Okay, questions? Now you may have got an overview, right? To have a big concept of all those. Now it's time to have a recap of this chapter. 36. It is. Have you all copied it down, right? All copied. Now find some time on capturing this. We will have a consolidation of this topic to wrap up what we have learned so far. Questions? No? Now, if not, we come to here. You may know we will come to mainly the methods of monitoring the progress of a reaction. So you may find the first four being the physical method, while this is the chemical method. Okay, and now and afterwards you may be given a graph, right? So you may plot a graph. So you may plot a graph and they will show the progress of reaction, and you need to interpret this one. For example, the change in reactant concentration versus time. That will be show you a curve like this. While for the change in the concentration of product versus time, it will give you a curve like this. Okay. After doing this curve, what should be done is to quantitatively tell which part is faster, which one is slower. Okay, it is done by what? It's done by plotting, finding the instantaneous rate at certain time. But most of the time, we would use the time is equal to 0, being a initial rate. How can it be done? Is by plotting this, is to enlarge the diagram and find out the tangent. Find out the tangent, and you determine the slope. So this is the instantaneous rate. At time equal to 0. In short, we also call it as initial rate. So either this or this, you can also get it as an initial rate. But of course, that two graph is different, right? The one on the left-hand side, we will call that the initial rate of a formation. Okay, the formation of a consumption of the reactant. While on the right-hand side is the rate of the production of the product. Is different. But of course, the data will also be different. This one, it is a negative data, while this one is positive. So in order to get to know the difference between them, you just focus on magnitude, but not plus and minus. But of course, plus and minus give you a meaning. Minus, which means that some those chemicals they are consuming. While you got the slope being plus, which means that forming. Consuming something, which means that they are forming something. So while the slope, they will have a decreasing trend in magnitude, which means that's the fastest rate of consumption of reactant happens at the very beginning. While the rate of formation of product, it is found to be highest at the very beginning. Questions? So you may get to know this. Any questions so far for that? So all those they have covered. Now together with the concept of doing some calculations, right? So you may get to know something more about mathematics behind. Now today we will focus on the on some of the chemical on this MC, first of all. Number 2, 3, and 4. 2 and 3 mainly, right? It is choosing the appropriate method to monitor the progress of the reaction. You may have 4 choices to choose. 1 is calorimetry. 2 is collecting and measuring the change in volume of gas at regular time interval. C, measuring the change in mass of reaction mixture. And 4, doing the titrimetric analysis. Which one would you choose for question 2? What is that? Now you may find these strange chemicals, right? You may not be so comfortable with that. So what is that? We call it organic chemicals. Well, organic chemicals, what is the color of it? What is that? We call it an ester. This one is methanol acid. Well, for this one is a type of alcohol. We call that methanol. Well, the ester here, we call that methyl methanoate. So take a look on the nature of the 4 chemicals. Can you choose the most appropriate method? Now, do you know the color of the 4 chemicals? Do they have any gas form? No. What are the color of them? What are the colors of those 4 chemicals? Lam Yifeng, you know it?
I don't know.
You don't know. Check. Most of the time, organic compounds, what are they as the color? For example, methanol capsule. So what is that? In industrial spirit, right? You know that ethanol is the alcohol that you can drink. Okay, for human can drink. So what is the color? Do you know? 乙醇係咩色㗎？甲醇其實同佢色同乙醇一樣嘅，知唔知咩色啊？唔知，小華記啦。These are the chemical 咩色啊？ What are the colors of that?
Colorless.
All 4 are colorless. So you please choose the most appropriate method. Which one?小華記。
Quenching. I mean D. Yeah.
D. You may choose D. Yes, you are going to keep track of what? The titration with standard alkaline. What concentration of which chemicals are you going to consider is on this? Because it's an acid. So you are going to measure the change in concentration of acid by doing titration. Do you follow? Do you follow our concept, right? Do you know how to choose? Now, number 3. Now you use the same logic, right? Think about number 3. What would you choose? A, B, C, D. What would you choose? What method is suitable? Yes. Question 3, please. Hey. A. Why? Why would you choose A? Hello. Oh, him, why you choose A? What is the observation during the whole progress of the reaction? Oh, he.
Color change.
Tell me, what is the exact color change? At the very beginning, we have got two chemicals. The one on the right-hand side, left-hand side. So what is the overall color of the two? So what is that for first one? First one, we call it propanol. Now for simple organic chemicals, it's colorless. Now my focus is on here. What is the color of this? Hey? Oh, here. What is the color of this? Now I will express my worry on your class, or maybe even your whole year of students, the whole batch of students, by not being able to memorize some basic chemical stuff, especially the color of the solution. What is the color of iodine solution? Now my random sampling. Random sampling. If I have got 3 consistent results, can I say that for your whole class, you cannot know the color of iodine solution? I will pick 2 more students, to justify my claim. What is the color of iodine solution?
It is brown color.
Brown. Yep, good, brown. So during the whole progress of a reaction, what is the color change?
It changed from brown into purple.
Brown to
Purple.
Purple. Which chemical is purple? Finally,
The iodine.
Iodine is purple. It's purple. Agree? Iodine is purple. So what is the color change during the whole progress of a reaction?
From brown to purple.
Brown to purple. 真好正. What is the color change of a solution mixture?
From brown to colorless.
Colorless. So iodine ion. What is the color of an iodine ion in the aqueous solution?
Colorless.
Colorless. Sure.
Yes.
You say it yes, but you just raise the tone at the end. You just tell me yes. Yes. So what is mean by is it a insurance of telling me iodine ion being colorless? I ask you, are you sure? It just says yes. Now indeed, iodine ion, they are colorless. So during the whole progress of a reaction, the brown color, okay, of the solution becomes paler. Now, so this is what I would expect. You should know this, something like this. During the whole progress of a reaction, the brown solution becomes paler. And until the end, right, in case iodine, it is the limiting, the final solution will become colorless. If iodine is in excess, okay, the final color of the solution is just pale brown or maybe yellow, and they will just stop being more paler, okay, afterwards, in case the reaction has come to an end. Okay, Now, because we have got a change in color intensity of a brown solution over time, you can use colorimetry is by it to keep track of the change in absorbance. Now, I just tell you the keyword, right? Absorbance of the solution mixture over time. Now, so this is the way to answer that type of questions. Do you understand? 你已經好 question 4. Which of following is the most likely to have a highest reaction rate and room temperature? A, B, C, or D? Highest reaction rate at room temperature. Can you see the word at room temperature?
C.
C. C. C. What is the type of reaction? A reaction between metal and dilute acid. Now, first of all, now please take a look on the type of reaction of 4. Number 1, A. What is that? What is the type of reaction? Methane, oxygen to form carbon dioxide and water. What is the type of reaction?
Displacement reaction.
Displacement reaction. See the one here.
Hello.
I just want to say goodbye.
Oh.
Methane, oxygen, carbon dioxide, and water. So what is the type of reaction? My hint is the type of reaction in A is equal to that in D, the same. What is the type of reaction?
It's physical.
Physical. Is a chemical change a physical what? Physical what?
Huh?
You would like to go back to Form 3? All 4 are chemical changes. I don't know. I just doubted. It's a matter of language, but it seems not. Have I collected enough evidence to make my conclusion? Makinya. Makinya. What is the type of reaction between A and D? The same answer for A and D. What is the type of reaction?
I don't know.
You don't know. You better take a look on the facial expression of some of the students. It comes as a surprise for everyone. Anyone who can tell, what is the type of reaction?
Mr. Chin, is that a combustion reaction?
Thank you. Thank you. Who just said that? I cannot recognize your name. Who are you?
I'm Lee King Ho.
Oh, you finally know it.
Yes, I just found out.
Combustion, burning. How about this? The reaction between metal and acid. How about B? What is B? Precipitation reaction. Which one is the fastest? The answer is B. Okay. Precipitation reaction is the fastest. Why? It involves just a collision of the 2 types of ions in aqueous medium. Now, because in the aqueous mediums, those ions are mobile, which means free moving. So whenever they meet, they will soon form a precipitate. but not for A and D, because at room temperature, burning them, they will involve ignition. For example, a spark. Okay, without the spark, the reaction cannot go. How about C? You may think that it's a metal and acid reaction, but the reaction happens on the surface. But you may find that this solid and this solid, which means that they will have a, while the reaction proceeds, there may be a coating effect. Okay, you may have a coating effect. So the reaction is not so fast as you may expect. Questions? Do you still remember what is meant by coating effect? Still remember? Okay, how about this? Question 8. You're going to use a pressure sensor to follow the progress of a reaction in a closed reaction vessel of a fixed volume. The graph will show you like this. So among the 4 choices, which one might the graph represent? That equation, which reactions might the graph represent? A, B, C, or D? Not hint. Not hint. What do you think? A, B, C, or D? Now, whenever you talk about pressure change, so it should involve a chemical of certain physical stage. So what is the physical stage? You need to check. Solid, liquid, aqueous, or gas. In pressure. Hello. Yes, turn on the mic and let me know.
Solid, liquid.
Solid and liquid. Pressure. Do you know the Chinese name for this pressure? What does it mean by pressure? So you may find this one of it, ATM. What does it mean by ATM? You know it, atmospheric pressure. So what type of pressure does it measure? Solid, liquid, aqueous, or gas?
Gas.
Gas. Do you understand? So just underline those chemical evolving gas. This. Just B or C. Okay? Are there a possible answer? Which one is the answer? B
C.
or
C.
C? Why? Why is it C? Now there should be a reason to support your answer. Now B or C both involving the reaction between the of gases to form another gases. But why would you choose C but not B?
More molecules present in the same volume increase the pressure.
Oh yes, that's right. Good. So you may find during the whole progress there is an increase in number of moles or number of gas particles. Okay, because you are going to talk about in fixed volume. So of course, if I have got the number of moles of gas particle is fixed volume, the pressure of a system will increase. Why? So what is meant by gas pressure? Gas pressure is a measurement in which the particle that will hit on the wall of the container per unit area. So in case you have got a fixed container, but you have got more particles, what will happen? So more particles they will have they will hit of the wall of the container. It exerts as a higher pressure. Do you get my point? Once you hit, okay, once you will have a particle hit on the wall, it exerts a force. Okay, the more particles that hit to the wall, the more force they will apply to the unit area of the container. So we call that a measurement pressure. So that's why pressure, if you study something about physics, you may find a expression like this. The pressure is equal to force over area. Okay, how much force will be applied per unit area? So area here refers to the area of the wall, of the container of the wall. Do you understand? So more particles on that, inside the more force that we apply, but the size of container doesn't change, which means that per unit area of the wall, it will experience larger force because that pressure will be higher. So that's why C. How about B? What is bad about B? If I use this one to measure the change in pressure over time, so you may get a curve like this. So remember, a flat curve, but this one is 1 atm. If you are chose to do so, it's 1 atm only. Why? Because there, during the whole progress of reaction, there is no change in the total number of moles of particles. The chemical nature has been changed, but the total number has not been changed, which means that at the same temperature, same volume, the per unit area of the wall of the container experience the same force because of the heating of the gas particles onto its wall. Like simply like this. Okay? Do you understand? So you may have got how about if you are given a equation in which they will experience a drop in the number of moles of gas particles. You may also use pressure sensor for help, but for the graph, it will not be this. It will have a dropping trend. Do you understand? So I just want to remind you something about question 8. Question 9, we have done that. Question 10, we have done that. How about question 11? Macross experiment. So the apparatus shown was set up to measure the time taken for the 20.0 cm cube sodium thiosulfate solution to react with 5.0 cm cube hydrochloric acid in a 100 cm cube conical flask at 20 degrees. The timer was started when the two chemicals they are mixed, and the timer will stop when there is no longer possible to see the cross on the paper. Now, when you will from the above. So the question is, which of following is likely to decrease the accuracy of the experiments? So you do something, right, that may affect the accuracy of the experiment. Which one would be a possible choice? Gia Jing. Which one would, which practice it cannot be done? Which practice cannot be done? A, B, C, or D? Must not be done. Otherwise, data must be incorrect. A, B, C, or D.
B.
Stirring of the, why you think A is B? Stirring the solution throughout each experiment. Why you think is B? Why you choose is B? So what effect will it bring if I stir the solution for the experiment?
Increase the rate of the reaction.
Or increase the rate. But if I do not stir it well, if I do not have a thorough mixing, what will happen? The reaction can only happen when the two chemicals meet. So, which means that the cloudiness of the solution mixture over time is not a uniform one. Okay, some places will have got a more cloudy area, while some is just not cloudy. Can you get my point? So you should stir the solution before you track the time. At the same time, you're going to count the time. Okay, all those should be included. Now, otherwise, the color change is not uniform. Is needed. B is needed. Okay. You choose again. John Dollar, choose again. Which one will you choose?
A.
Why is A?
Because it will increase the number of moles of acid than actual that I used.
Mm-hmm.
So
yes.
More number of mole of acid is used to react with the sodium thiosulfate.
Mm-hmm.
As maybe more sulfur is formed, so it decreases the accuracy of the experiment.
By having the time being faster or shorter than expected? Shorter, which means the rate is measured to be higher than expected. Okay,
yes.
so that is the logic, right? So indeed, I increase the, it's not just increase the number of moles of active molecules, but also increase the higher ion concentration. Because I would have a fixed volume of our solvent air, right? But for the acid, I add more to it, so it will affect the molarity of it. So it will much decrease the time or for the completion, or for the time taken for the macros to be blotted out. So the rates to be measured will be much affected. Okay, how about C and D? No problem, because for C, that is highly needed. You must use the same piece of paper. For D, you use different measuring center to measure the volume of acid and sodium thiosulfate. As long as every time you use the same measuring center for each of the chemical, the accuracy will be minimum. But of course, if you choose different measuring center, just like the first one is 10 mil measuring center, or the other one is just 100 mil of a measuring center, of course the error will be quite big. Because especially for using 100 mil measuring center to measure a very tiny volume of a solution. Now you know that the grading will not be so precise. So that may more or less affect our accuracy. So amount of 4A must be the totally wrong answer. But for D, D may give you some errors, okay, but not a wrong practice. But A must be wrong. Can you get my point? Questions? Now we come to the final two MCs. Question 12. Yong Seng-hin. Yong Seng-hin.
Is it B?
Is it B? I just answered you the question, but not you just passed me back the question. The answer is B. Why?
Because only 1 and 3 have gas produced.
Yes, 1 and 3 you have got gas produced, but not 2. 2 no, but you are going to measure the change in the gas formation, right? Volume of gas form. So this would agree. We use a gas arranger, it will help. Final question number 13. McKinney, I'll give you another chance. A, B, C, or D? Hello,
B.
Mr. Mai. Now you tell them one by one. Number 1 is okay.
Okay.
Okay, what is the color change of the reaction? What is the color change of a reaction?
I don't know. I
咁
only
你得 OK? Because we have got 3 choices having number 1 here. So according to probability, there will be a high chance of having 1 to be answered. So you say that 1 is okay. But sadly, the equal chances can be found for statement 2 and statement 3. Count the number of statement 2 and statement 3 in the 4 choices. They are also 3 chances. So the probability of wondering about is still 3/4. But it's not correct, right? So only 1 is the answer. There is a color change. So what is the color change? Anyone who can tell? It seems that we go back to prehistoric times, but not a Wi-Fi times, right? It seems like communication among us is very, very difficult. Tell me what is the color change?
Is
What is the color change? Yes.
is it purple to light pink?
Pale pink. Okay, pale pink.
Okay.
Pale pink for manganese 2, purple for permanganate, P for purple, permanganate. Tell yourself 21 times. Permanganate, P for purple, okay? P for purple. P for purple, P for purple, P for purple. 記到未？由細讀到快 P for purple 嘛 ，permanganate 咪紫色咯，得未？記到未啊？ So what the color intensity of a purple solution drops. The purple color drops in terms of intensity. So we will use colorimeter to measure the change in the color intensity of a solution. Yes, this 1 is okay. How about number 2? 曾浩正. Can we choose 2?
Yes.
Why?
Because the carbon dioxide gas is formed. So after the reaction, we don't have to calculate the mass of carbon dioxide gas.
So what is the change of the mass over time?
Decrease.
Yep, decrease. So how would you measure the change in mass?
Electronic balance.
Yep, electronic balance. How about number 3? Now hold in again.
Yes.
Yes, refer to the answer that number 3 can be chosen, or you just respond to me that you are going to answer.
3 is correct.
Yeah, see, why?
Hydrogen ion.
Hydrogen ion. So what happens to hydrogen ion? Your response will not give you marks. What happens to hydrogen ion?
The concentration of hydrogen ion decrease.
Yep, hydrogen ion concentration decrease. So which means that pH value of a solution, what's the change? What should be the change?
Increase.
Yep, increase. How will you measure? How will you measure?
Orange.
How will you measure? You use some. We simply use pH meter for help, but not methyl orange. Because methyl orange cannot tell you the exact pH. Use pH meter. Okay, so the answer is D. Do you understand? Now, so we may take some more time on doing the long question in the next lesson. So before we end up the lecture today, I would just go over review different methods. So for MCs, you may find it difficult to you because it seems you are not so familiar with the type of reaction. But don't worry, you use our same procedure, same flow, and you can solve. Simply, first of all, check any gas formation or production, formation or consumption. If that is the case, use physical method. For example, gas syringe can help. Change in measure the decrease in mass can help. Do you understand? And second is keep track of any color change. Usually, transition metal ions will have that certain color change. Remember that. And number 3, if you find that all those solutions do not have showed such observable change, but you find that all those colorless solutions they turn to colorless, but you may find some acid or alkaline on either side, you use titrimetric analysis. Can you get my point? So marks the end of today's lesson. Okay. Before you go, could you please put it 0 to 10 before you go? Now we have got the next lesson right away. Now please type it as quickly as possible before you leave. Now once you type it, you say goodbye and you may now go to another classroom. Bye-bye. Okay, bye-bye, Chem 1.
Bye-bye, bye-bye.
Bye-bye.
Bye
Bye-bye.
bye.
Bye-bye. 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 Bye, guys.
Bye-bye.
Bye-bye.